Okay, we're now going to look at an example that deals with electrical power and energy that's being dissipated through a circuit. So we want to look at the relationship between energy and power. And if you recall from before, when we studied mechanics, we learned that power was the rate of doing work, so joules per second. Um, so in every electrical circuit, like a light bulb here being powered by some batteries, there's something that is providing a constant voltage source that is lighting the light bulb, and as that charge is passing through the light bulb, remember the charge is not being used up, it's really the energy that's being used up. So what we want to do is first just to show you how this is defined, the term power. Power is work over time, and the work is the amount of potential energy. So as the charge passes through the circuit element, the work done by the charge is equal to the product of the charge multiplied by the voltage across the circuit element, in this case the light bulb. So Q times V is your work, and that's divided by time. And if you recall, Q divided by T is really the definition of current. So you can now rewrite power as current times voltage. Now there are a variety of other forms. If you were to replace, for example, voltage with current times resistance, you would get this form, I squared times R. Or if you were to replace current with voltage over resistance, you would get this third form. On the AP formula sheet, you're really only going to have power equals current times voltage, but you are given Ohm's law right here, and so you should be able to get the other two forms easily. So now let's get on to example number 4. We have a flashlight that has drawing a current of 0.4 amps through this bulb or filament. So our current is 0.40 amps. The voltage across the circuit element is 3 volts, and we're asked to find the power. And so the power is simply calculated by current times voltage. That's 0.40 amps multiplied by 3 volts, and that gives you 1.2 joules per second, or 1.2 watts. Okay, now going on to part B, we want to know how much energy was dissipated. So energy is really work. So work would be equal to power times time, and we must have been given the time, and yes we are, 5.5 minutes. So you'll need to convert that to seconds, which is 330 seconds. And now you can substitute that in. Your power was 1.2 joules per second multiplied by 330 seconds. You can see the seconds will cancel out, and so you'll get an answer in joules. And so the energy dissipated in the circuit is 396 joules. And that's it for example number 4.